everyone, welcome back to Hessel Press, your source of information. My name is Sarah, and today, as we come close to beginning the new year, we will discuss perhaps the most exciting discovery made so far, a potential biosignature found on Mars. In July 2024, NASA's Mars rover Perseverance collected rock samples in the Jezero crater, a region believed to have once hosted an ancient river and lake system. The area has long been of interest to scientists due to its dry riverbeds, sedimentary rock layers, and mineral deposits, which suggests the existence of water that once flowed 3 billion years ago. The specific samples in question, collectively referred to as the Cheyava Falls, were taken from a rocky region known as the Bright Angel Formation, which lay within the crater's river delta. Upon further analysis of these samples, NASA uncovered what could be the strongest evidence to date of ancient microbial life on the red planet. These rocks contained unique patterns of minerals, particularly iron phosphate and iron sulfide compounds. These compounds on Earth often formed as a byproduct of biological activity. Due to their unique shapes, these mineral formations were dubbed by scientists as leopard spots due to their dotted appearance. Perseverance's instruments were able to detect a mix of compounds such as organic dissolved carbon, sulfur, and phosphorus, all key ingredients that carbon-based life forms depended on to survive. These findings came from two of Perseverance's tools, Pixel, which identifies chemical elements in rocks, and Sherlock, which can detect organic molecules and minerals linked to habitability. Even though NASA classifies these findings as potential biosignatures, as in they might indicate past life, it is yet to be fully confirmed whether or not these could indicate the existence of full-on life in our solar system. While the mineral textures and chemistry align with those produced by microbes on Earth, there is still the possibility that they could have been created entirely by abiotic chemical reaction. However, surprisingly enough, the surrounding rock does not show signs of the extreme heat or acidity that often drives those abiotic reactions, which strengthens the interpretation of them being biological. What is particularly interesting is that these samples that Perseverance was able to find are among the youngest sedimentary rocks that it has been able to investigate so far. Up until now, many believed that any signs of life on Mars would be found in the oldest of samples due to the theory that Mars may have remained habitable for a longer time than previously thought. From a scientific impact perspective, if the signs of microbial activity are validated, this discovery would pretty much reshape our understanding of Mars. It would mean that life didn't just have a fleeting chance, but maybe persisted in conditions we hadn't expected it to, and possibly prospered. It would also reinforce the idea that habitable planets may be more common in the universe than some physicists suggested they to be. Even if the conclusion turns out to be abiotic, the finding still signals that Mars had a rich chemical environment capable of sustaining life-friendly processes. Another point to consider is the mission plan and what comes next. The Perseverance rover has been catching rock cores for return to Earth under the Mars Sample Return campaign. The sample from Cheyava Falls is among those intended for future retrieval. Once these samples are returned, Earth laboratories with far greater analytical power than the relatively limited ones on Perseverance will be able to determine their isotopic compositions, molecular structures, and other definitive markers that could turn this hypothetical into the new cornerstone of astrobiology. Thank you for watching. If you enjoyed our content, don't forget to like and subscribe. We hope to see you in our future uploads. Until then, it was Hessel Press.